There's a video that shows copper pennies turning into silver and gold. Please watch that video and answer the following questions. First of all, make 2 or 3 chemistry observations, and then answer this question. Do you think the copper penny really turned to silver metal and then to gold metal? And how could you check to see that the pennies are really silver or gold? Here's a flow chart that shows the relationship with all matter. So when we go to classify matter, we want to ask the question, can it be physically separated? If it can, then we know that we have a mixture. Mixtures are just physically combined. They're not bonded together. If we have a mixture, then we can look at if the mixture is uniform. If it is, then it's called a solution or a homogeneous mixture. If it is not uniform, like it can settle after a few minutes or even days, then we know we have a heterogeneous mixture. Most things in our world are heterogeneous mixtures. We can see different colors in a substance or different phases, solid, liquid, and gas. When we look at pure substances, we can see that it is separated into elements and compounds. Elements will always be on the periodic table. If it is not on the periodic table, it is not an element. Compounds are elements that are chemically combined or bonded together. And you need to have at least 2 different elements combined to classify it as a compound. Some definitions. Homogeneous means the same throughout, and elements, compounds, and solutions or homogeneous mixtures fall under this category. And that's because you can't see any differences. The compound is composed of 2 or more different elements, but it is its own little group. And because it's its own little group that cannot be physically separated, then it is considered homogeneous, or there's a sameness to it. Heterogeneous means that it's different throughout. Should be able to see different colors or different phases, solid, liquid, or gas. There should be some sort of difference there. Let's talk about elements. First of all, as I mentioned before, they have to be on the periodic table. So whenever you're classifying matter, you want to have a periodic table that you can refer to. If you can't find it on the periodic table, it is not an element. An element is composed of the same type of atom, and it is homogeneous, which means the same throughout. Some examples are copper wire, which is just composed of copper atoms, and aluminum foil, which is composed of just aluminum atoms. Elements can be monatomic or diatomic. Monatomic just means that the atom in the element can be all by itself. Some examples are iron, gold, silver, lead, sodium, and carbon. And you might notice that sometimes the name doesn't match the symbol. And that is because they are taking the symbol from its Greek or its Latin name or its ancient name. For example, gold is Au, which comes from its ancient name of Arum. And so they've just taken that ancient name, the first 2 letters, and that is a symbol for gold. Now, diatomic elements, these are elements that have to, their atoms have to be bonded to another atom. So it can be bonded to the same atom. So in other words, I could have 2 hydrogen atoms bonded together, or it can be bonded to a different element. In that case, it would be called a compound. But these are atoms because of the nature of the element, they need to have a buddy. Here are the diatomic elements right here. There's 7 of them. A good silly sentence to help you remember these diatomic elements is have no fear of ice cold bears. So hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. They also make a 7 on the periodic table. So if you look at a periodic table, it makes a 7 right here, starting with nitrogen, over to fluorine, and then down to iodine. And then you need to remember that hydrogen is over here. So we can count 1, 2, 3, 4, 5, 6. We really are never going to have that one at the bottom there. So go down to iodine, and then remember that your 7th is hydrogen over there. So those are the diatomic elements, and remember they always have to have a buddy. They have to be bonded to another atom. You just can't write an H, you have to write an H2. Chemistry can be divided into 2 types of study. One is organic chemistry, which is chemistry that involves carbon and the bonds that carbon makes. And this is more life chemistry. And then there's inorganic chemistry, which is everything else. And you might think that everything else, that would be harder, but it's actually a little bit easier because carbon makes very complex chemical reactions. So in this class, we are going to be studying inorganic chemistry, which is non-carbon chemistry. Compounds are homogeneous, and as I said before, they are composed of two or more elements that are chemically combined, and they're combined in a fixed ratio. Oftentimes, they will have a formula, and that formula will show the ratio. The properties of the compound will be very different than the elements that form the compound. To separate a compound, you have to use a chemical change. Physically, you cannot separate the elements in a compound from each other. Some examples are table salt, NaCl, and sucrose. So this is table sugar and table salt. So in table salt, we have sodium, which I can write like this, Na, and we have chlorine, which its element is Cl2. And when they chemically combine in a chemical reaction, then I get NaCl. And you can see that the ratio is a little bit different than how their elements are written. So one sodium is paired with one chlorine. And so the formula is a 1-to-1 ratio. When we have table sugar down here, notice there's 12 carbons for every 22 hydrogens and 11 oxygens. And so this is carbon chemistry or organic chemistry, and this is a molecule of sucrose. You can always tell a compound again because it has a formula. Mixtures are two or more things physically combined, and I can have a homogeneous mixture or a heterogeneous mixture. And these can come in solids, liquids, and gases, so they don't always have to be liquids, and they don't always have to be solids like is shown here. When a homogeneous mixture or a solution is a liquid, it often is see-through. And that's because the particles are really, really tiny. So here's some apple juice here, and you can see that the apple through the apple juice because as a liquid solution, it's clear. A heterogeneous mixture, this is anything that you can see differences. And here in this rock, I can see different colors. Let's talk about solutions or homogeneous mixtures, and you should know both terms. Remember, they're going to look the same throughout. They have very, very small particles. They will only have one phase of matter. So it will all be a liquid or all be a solid or all be a gas. The particles don't settle out in any of the phases. And I already said if a liquid solution, you can see through it. A good example is rubbing alcohol. And here's a picture of rubbing alcohol. The picture's a little bit small, but it says 70%. And that means 70% alcohol. And then the other 30% would be water. So this is a solution that has alcohol and water. They're both liquids, and they both mixed evenly, and they will stay mixed forever. Brass, this is a solid. It's a solid solution. And so they take and combine zinc and copper, and they melt it together, and then they let it solidify, and it is a solid solution. So it looks the same throughout. Those atoms are combined physically, and so that's why it's classified as a mixture. The air we breathe. So air is mostly nitrogen, and it's also oxygen. And so the oxygen we breathe, that keeps us alive. There's some nitrogen in there that our bodies can't use. And so we end up just breathing in the mixture of nitrogen and oxygen and some other gases. And then we breathe out carbon dioxide, a little bit of leftover oxygen, and then all of that nitrogen. Now, solutions or homogeneous mixtures are composed of at least two things: solutes and solvents. The solute is the dissolved material, so that appears in lesser quantity. The solvent is what does the dissolving, and water is the universal solvent. Now, there's a lot of S's here for solutions. So how I remember this is the U in solute will go into the V in solvent. So I remember the U goes into the V, and that's alphabetical order with the alphabet. So U goes into the V. So solute always goes into the solvent and gets dissolved. And here's just a picture of a sugar solution. So the sugar is the solute, and it's going into water, which is the solvent. Heterogeneous mixtures are mostly what we see in our world. They are different throughout. They have many different states of matter. You can separate them physically. Look at this salad down here. Could you pick out all the components of the salad, pick out the tomatoes, pick out the bell peppers and the lettuce? You could. And so in many heterogeneous mixtures, you would be able to separate the things that are mixed. Here's a picture of ice water here. And you might think, isn't water H2O? Isn't water a compound? And the thing that makes this a heterogeneous mixture is the ice cubes. They are a solid, and they are floating around in a liquid. So anytime you see differences, it's classified as a heterogeneous mixture. Even if it looks like our ice water, it's the same stuff. As soon as you have different phases, it's heterogeneous. Milk is a good example of a heterogeneous mixture. Sometimes you need to look at it very, very carefully and with a microscope to see the differences. So when you look at a glass of milk, it's opaque. You can't see through it. So that's kind of a clue that it's not a solution. Because remember, we talked about solutions tend to be see-through. But down in a microscopic level, you can see these little fat globules here. So even in fat-free milk, it has a little bit of this. And so it is still considered a heterogeneous mixture, again, because you can see differences here. So let's just practice this. Stop the tape, see if you can figure out if this is a heterogeneous mixture or a solution. Okay, we're back. So Kool-Aid. So if I can picture in my mind a glass of Kool-Aid, it is classified as a solution, and that's because it's see-through. Concrete, this is a heterogeneous mixture, so it will have air bubbles in it or rocks in it, and that is a difference there. We just went over milk, it's a heterogeneous mixture. Fruit salad, I can see the different components that go into making the fruit salad. So air pollution, so we know air is a solution, and if you add little particles of smoke, that would make it a heterogeneous mixture. And soda pop. Soda pop is a heterogeneous mixture, and that is because of the bubbles that are found in the soda. And so those are different phases. I have both a liquid and a gas. Do this set, so classify it as an element, compound, a solution, or a heterogeneous mixture. Go ahead and stop the video and then see if you can figure it out. Okay, here are the answers. So graphite is actually carbon, and those are just a different name. Graphite is a different name for carbon, and I can see carbon is on the periodic table, so this is an element. Pepper, if you look at pepper, it has black and gray and sometimes white little colors, and so those different colors tell me that it's a heterogeneous mixture. Sugar or sucrose, we talked about this. This is a compound that has a formula. Paint can settle after a while, so that lets me know it's a heterogeneous mixture because it doesn't stay mixed. Gatorade is kind of like Kool-Aid, and it's see-through. It's a liquid solution. And baking soda has a formula right there, so that tells me it's a compound. Okay, newspaper, whether it has ink on it or not, if you hold that paper up to the light, you're going to be able to see differences with the wood pulp that makes the newspaper. So this is a heterogeneous mixture. Nitrogen is on the periodic table. It's an element. Water is a compound. It has the formula H2O. Propel drink, so that's like Gatorade or the Kool-Aid that we've talked about. It is a solution. Leather, if you look at it, it comes from an animal. It has animal cells in it. That is a heterogeneous mixture. So you should be able to see differences there. Snow cone syrup. So this is a clear liquid solution. Magnesium is on the periodic table. It's an element. And magnesium chloride, that is a compound. So often with a compound, they'll list the names of the elements in it. So we have magnesium and chlorine that are chemically combined.